Hello everyone, my name is Jawad Ahmed Farooq and this is my presentation for the IDM course project. I worked with Akil Ahmed and Sheikh Abdul Monim on solving the LCV Cup scheduling problem using answer set programming with Klingo. This project involved modeling a real world fixture generation task with complex constraints and solving it efficiently with the Klingo solver. So let me give you a brief overview of our project. The goal of the project was to generate match calendars for a non-professional football league. The core challenge was to ensure that all matches were scheduled fairly and feasibly, which meant taking into account the availability of the teams and the availability of them being available to play at home or away. We used answer set programming to encode the problem logic and ran it through Klingo to generate valid schedules. The project emphasized respecting hard constraints like team availability, as well as minimizing soft penalties such as teams playing together and checking the time slots of the teams being available at home or away, and also managing to schedule as much as possible games. So, if we look at the whole system that we generated, we created a pipeline in which where we could input the availability matrices of a team and generate a calendar. In order to do that, we took the input matrix, which was basically availability matrix of of the team being available at home or away. We then passed it using Python, and in order after passing it we needed to generate facts because the Klingo solver needed the facts that if a team was available to play at home, if a team was available to play away, and what were the time slots of each and every team and how they overlap with each other. So in order to generate those facts, we used Python and we created an encoder which could basically transform that input matrix into high level facts so that we could feed it to the Klingo solver. That is how we use the encoder. After encoding, once we had those facts, we put it through our Klingo model. The Klingo model had all the constraints that we needed the Klingo solver to take into account when generating the calendar. So those facts were fed to the Klingo solver, and after the Klingo solver had those facts, it would generate a stable model. So the stable model was basically the schedule that Klingo was giving us based on the constraints and based on the facts that we had given it. Once we had that stable model, we again used Python to convert it to a calendar output. It was basically a matrix which would tell us that which match could be played when, how the schedule was looking, and that's how our whole pipeline worked. So now let's look at what we as a team achieved. As a team, we achieved a number of things. First of all, we successfully modeled the entire fixture scheduling task using ASP, including both hard and soft constraints. We incorporated complex rules like enforcing rest periods using the Rmax parameter and spacing between home and away games using the parameter. We tested multiple heuristics to guide the Klingo solver, which included prioritizing tight pairings and less contested slots. This improved the solution feasibility. Additionally, we benchmarked our schedules on real and synthetic instances and compared them to the results of the original paper. Then we experimented with Klinger configurations such as opt-in, VMTF, and IP heap, and there were some other configurations as well. This was mainly to reduce the time it took the Klinger solver to find the optimal solution. And throughout this project, we used GitHub to communicate with each other and keep track of what needed to be done. We created GitHub issues and reviewed each other's PRs to help with the coding process and to ensure that everyone was collaborating easily together. After that, we once we had the calendar generation process, once we were getting some calendars, we wanted to validate that all our constraints were being met. And in order to validate our calendars, we used a Python based validator to verify that every calendar we produced satisfied all the six hard constraints. These included notable booking, valid availability, and enforcing Rmax recovery periods between matches and spacing repeated matches between two teams. To test our validator, we manually created synthetic calendars with known violations, like a team playing twice in one slot or too close together, and we feed it through our system. This helped us catch any logical bugs and confirm that our model respected constraints properly. Before benchmarking, we made sure that every solution passed validation and only then calculated the scores and compared them with the original paper. This gave us some confidence that our results were both correct and meaningful. So, my contribution to this project was mainly building and refining the encoding pipeline. I designed the Python script that basically was a wrapper around our whole project. Uh, it read the instance matrix and converted it into ASP facts so that we could feed it to the Klingo solver. Rather than using abstract values in the ASP model, we moved all the interpretation into Python, which made the model cleaner and easier to maintain. So the model just had the constraints, no logic of pre-processing or anything that was not necessary for Klingo. I also handled calendar generation from Klingo's answer sets. So once the Klingo answer set was there, once we had a stable model, I used Python again to convert it to a calendar. Beyond that, I helped experiment with the advanced Klingo configurations. So I helped with the testing of those Klingo configurations and checking different configurations and how they were affecting the Klingo solver. So our final model achieved results that were competitive with those reported in the original research paper. For example, on instance 14, we got a penalty cost of 1062 in 166.9 seconds, while the benchmark paper achieved 1015 in just 30 seconds. This shows that ASP can be slightly slower, but it still performs well and is much more flexible for prototyping. And that's pretty much what we did in this project. Thank you very much for listening.